Hey everybody, this will be section 11.5 on the volume of pyramids and cones. I'm going to present my screen so you can see the handout. All right, should be good to go. Okay, so we're looking at the volume of pyramids and cones. Yesterday we looked at the volume of prisms and cylinders, so this is the next two shapes we're going to take a look at. Remember, we're talking about volume still, which is the space inside a 3D object. Surface area was talking about painting the outside surfaces. Volume talks about the inside. So we're going to look at pyramids and cones, which remember are very closely related. Just a recap from yesterday, how do we find the volume of a prism or a cylinder? We take the area of the base and we multiply by the height. So this was from yesterday. So the next natural question would be, how do we do this for a pyramid? And it's pretty closely related. What I'm going to do is I'm going to draw a pyramid that has the same height and the same base area as a prism. Obviously, they're different shapes, but I can make the base areas equal and I can make the heights equal. So in my picture here, say this little square on the bottom has the same base area as this square on the bottom, capital B. And let's say these two shapes have the exact same height. Okay. So I'm just comparing those two shapes, and what I really want to know and what I want to answer is this question right here in the middle. How many times would I need to fill up that pyramid, let's say with water? If I was to fill up that pyramid with water, how many times would it take to pour the water from the pyramid in order to completely fill up that prism? How many times would you need to fill up this one so that it completely fills up the one on the right with water? Take about 10 seconds, make a prediction. How many pours do you think you would need? So I'm just going to pause for about 10 seconds, give you a chance to think, and then I'll reveal. Moment of truth. How many pyramid pours will it take? Here we go. Not one, not two, but it'll take 3 times to fill up that pyramid before you completely fill up that prism with water. Okay? So what does that mean? That means that the pyramid is going to have 1/3 the volume of the prism, which would make sense. Doesn't it look like, I mean, look at the figure on the left. Doesn't it look like it takes up less space? It starts to have smaller and smaller space taken up as you go from the bottom up to the top, because there's only a point at the top of this one, but you got another base at the top of this one. It would make more sense that the prism can hold more, and it can hold 3 times as much water as the pyramid on the right. So that pyramid's going to have 1/3 the volume. Well, if the pyramid has 1/3 the volume of the prism, we already know the volume of the prism is the area of the base times the height. So for a pyramid, I need to put a 1/3 in front of that. It's 1/3 the base area. So like in this one, it'd be a square base, times the height, which remember is just the distance from the vertex down to the center of the polygon on the bottom. That's h. And we can do this for oblique pyramids too. The formula still works, even if your pyramid is tilted, because of our friend Cavalieri. We talked about that principle that said if you have 2 shapes with the same cross-sectional area and the same height, they're going to have the same volume. So I can still use this formula even if I shift that pyramid over to the right or to the left. So let's look at an example. First example we have is the pyramid. It's an arena in Memphis, Tennessee. They tell me the base of the pyramid has an area of about 300,000 square feet, and the height of the pyramid is 321 feet. We want to know what is the volume of the pyramid. I'm just going to write out my formula. 1/3 area of the base times the height. I really don't even need the picture for this one. They give me everything I need. They give me the base area as 300,000, and they give me the height as 321. So I really just need to plug it in. So plugging in B and H. In my calculator, you got to make sure that you put the 1/3 in parentheses. 300,000 times, and what was our height? Our height was 321 feet. That's a big number. That's a lot of space inside of that pyramid. 32,100,000 cubic feet. Remember, the units are not feet squared, but feet cubed, since we're talking about the space inside of that 3D object. Okay. So that's the amount of volume that shape takes up. Sometimes pieces will be missing. You'll have to do a little bit of math before you can actually plug into every single number in the formula. Let's look at this one. Find the volume in cubic feet of a square pyramid. So again, that means they're talking about the base being a square. The base edges are 40. So all of these on the bottom, these are all 40. And the slant height is 25. Notice they didn't mention the height. They're giving you L. So we're going to have to solve for H. So this right here they're giving you is L. But we can examine that little right triangle that stands up on top of the base. So I have that redrawn underneath. What I need before I get the volume is the base area and the height. The base area I can get pretty quickly since it's a square. All I do is 40 times 40. That's how I find the area of a square. So that's just 1,600 square feet. So that one, check. We already got that. Now the height, I know that this base edge is 40. And we've seen this trick before when we did surface area. If I want to go from the center of that square to the midpoint of that side, this little green piece that I am drawing right here is just the apothem, which is going to be half the length of that base edge, which is why I have 20. Okay. Little Pythagorean theorem to save the day. H squared plus 20 squared equals 25 squared. And then I'll subtract the 400 from both sides. 225, nice, clean, perfect square, tells me that the height is going to be 15 feet. So this distance from top to bottom is 15 feet. Now I have the height and I can plug in. 1/3 area of my base was 1,600. And then the height in this case was 15. Okay. This one you can type into your calculator. You give that a shot, kind of like I did the last one. Give yourself a second to type that in. See what you get. You should get 8,000 cubic feet. But that's how much space would be held inside of that pyramid. That's pretty much it for pyramids. You need the base area, you need the height, and then you need to remember to divide by 3 or multiply by 1/3. Cones work pretty much the same way. We've talked about before how a cone is very much like a pyramid. Here's your pyramid. Cone is pretty much the same, except instead of having a polygon on the bottom, now you have a circle. So it's not a pyramid, but it behaves very much like a pyramid. Same trick I talked about with water on the front. Let's do it with rice here. If I was to have a cone, here's my cone, with a base area of B. Well, a pyramid behaved very much like a prism. We've seen that a cone behaves very much like a cylinder. So let's just say that I draw a cylinder that has the exact same base area and the same height as that cone. So top to bottom is H for this one, top to bottom H for this one. And let's say this one also has a base area of B. Well, again, how many pores do you think it would take to fill up the cone so that you could completely fill up that cylinder with rice? And you would be right if you said it would still take 3 cones, just like it took 3 pyramids to fill up the prism. You're going to need 3 cones to fill up that cylinder, which means this cone has 1/3 the volume of the cylinder. Well, the cylinder's volume is area of the base times the height. So just like last time, for the cone, I'm going to have to put a 1/3 in front of it. You'll notice that that formula simplifies to this, 1/3 pi r squared h. And the reason for that is the base area is a circle, which is pi r squared. So your volume of a cone, you can use 1/3 bh, or you can use 1/3 pi r squared h. This is the one I usually go to, just because everything's ready to plug in. But you really got to make sure you remember that 1/3 in front. Otherwise, you're only finding the volume of a cylinder. Okay, so here we go. We have a nice oblique cone, a little bit tilted. Find the volume of an oblique cone with a diameter of 30 feet and a height of 25 feet. Okay, we're going to give our answer first in terms of pi, and then we're going to round it to the nearest cubic foot. So I'm going to write out my formula. 1/3 pi r squared h. Erase some of these dots. Well, I need a radius and I need a height. That's really all I need to plug in. They gave me a diameter of 30, which means each of these pieces here, the radii have to be 15. Cut them in half. And they actually gave me the height, which is 25. So I got everything I need. 1/3 pi times 15 squared. Make sure you notice it's a squared radius. Times the height is not squared. That's just times 25. In my calculator, I'm going to type in everything except the pi right now because they asked for it in terms of pi, and then later we'll type it in. I'm going to just do 1/3 in parentheses times 15 squared times the height was 25. So I get 1875. And then remember, you got to put a pi next to that. So this would be expressing that volume in terms of pi. But then they also asked us to round it to the nearest cubic foot, so nearest whole number. So now I'm actually going to take that 1875 and I'm going to multiply it by the pi button. So about 5,890 cubic feet. So that'll do it for that one. A little real world connection. Everybody likes ice cream. Let's just say you got 2 scoops of chocolate ice cream, or pick your favorite flavor, whatever flavor of ice cream you like. And the amount of volume in those 2 scoops of ice cream amounts to 10 cubic inches for both of them together. Okay. Now, say it's a really hot day. You're in July, and your ice cream starts melting into the cone that's holding it. The question is, will the ice cream melting into the cone cause it to overflow, meaning will it go over the top based on the dimensions of this cone that they give you? And if it does overflow, we want to know by how much. Well, if ice cream's filling up the cone, that means that we're very interested right now in the volume. We already know the volume of the ice cream scoops. In order to know if it's going to overflow or not, I need to know how much space is taken up inside of this ice cream cone. If it's less than 10, it's going to overflow. If it's more than 10, it should be safe. So let's look at what they give us. Here's our circular base on the top. Looks like they give me the diameter is 2. So I know the radius is going to be 1 inch. And from top straight down to bottom, they're giving me that the height of that cone is 6. Okay. So I'm going to have to compare the volume of the ice cream scoops to the volume of the cone. Okay. And this one we already know is 10. So the volume of the cone, use our formula, 1/3 the area of the base times the height. And since the base is a circle, I'm just going to plug in pi r squared. So I get 1/3 pi times radius is 1, 1 squared, height is 6. 6 times 1 squared would be 6. 6 times a third would be 2. This is about 2 pi. If you type that into your calculator, it's about 6.28 cubic inches. So I actually will type that in, 2 pi, because I'm going to need to figure out how much overflowing I have. So I'm just going to leave that on my screen, the whole decimal. Well, the cone only holds 6.28 cubic inches, and the ice cream has 10 cubic inches. So you are going to get some overflow. It's going to go over the top. This top right here is where it would hit 6.28 cubic inches. All this filling up with ice cream. So to figure out how much it overflows by, I'm going to subtract. I'm going to take 10 cubic inches from the ice cream scoops, and I'm going to subtract off the amount that the cone can hold. but I'm going to use the whole decimal. So I'm going to go to my calculator, 10 minus, scroll up, get my answer. Overflows by about, did they tell us what to round to? They did not, so we'll just do 2 decimals. 3.72 cubic inches. I'm just going to say of overflow. And we've done an ice cream problem before. The last one we did was a couple days ago. We looked at how much waffle material would be needed to make the waffle cone. That's a surface area problem because it's talking about the material on the outside of the cone. The ice cream filling up the cone, you're filling up the inside of the cone. The ice cream goes inside, not outside the cone. That's volume. So there's a difference based on the way that the questions are worded, whether you're doing surface area or you're doing volume. Last up for today, it wouldn't be a complete lesson without some funky shapes. We've seen these composite figures before. So I got 2 of them today. What we want to do is we want to find the total volume of each of these composite shapes, and we're going to round to the nearest hundredth, so 2 decimal places. First one I look at, it looks almost like a house. I can see there's a pyramid sitting on the top. So I'll outline that in blue. There's my pyramid. And then on the bottom, I've got a rectangular prism. So it's a pyramid sitting on top of a prism. So what am I going to have to find? I'm going to have to find how much space takes up the pyramid. And then I'm going to have to find out how much space takes up the prism. And since I'm stacking shapes like Legos, I'm going to add those 2 volumes together. I'm going to take the volume of the pyramid, and I'm going to add it to the volume of the prism. Okay. So it's like 2 mini problems. First up, let's do, it doesn't really matter which one you do first. Let's just do the pyramid. There's my pyramid. Looks like the height of the pyramid they're giving me is 6. So from top to bottom, that's 6. And it looks like, well, they didn't label the base edges, but I do know they're 4 because these are 4. And those distances have to be the same. So 4 all around here. There's my base. So I'm just going to do 1/3 the base area times the height. Base area is a square. 4 times 4 is 16. So 1/3 times 16, and then the height they gave me was 6. So 6 times 1/3 is 2. 2 times 16 is 32. So the pyramid's got 32 cubic inches of volume. Now I have to do the prism on the bottom. I'm just going to draw my prism. The bottom length and width is 4 by 4, nice square. And the height of, not the pyramid this time, the height of the prism is 5 from base to base. So from bottom base to top base, this distance here is 5. So I'm just going to do base area times height. Notice I don't have a 1/3 in front of it this time because it's not a pyramid, it's a prism. So I'm using the formula from yesterday. The base area is going to be 4 times 4, so another 16. And the height I'm using this time is 5. 16 times 5 is 80. So I get 80 cubic inches of volume. Last but not least, I have to add them together. So the volume of the solid, the whole house-looking object, is 32 cubic inches plus 80 cubic inches, which would be 112 cubic inches of volume. So just adding the volumes together. Okay, so that'll do it for the first one. The second one's a little bit different. At first glance, you might say, well, it just looks like a cube, right? It's got the same length, the same width, and the same height. But what you're going to notice is we actually cut a shape out of it. And what we cut out of it was a cone. I don't know if you've ever been ice fishing, but if you're ice fishing, you have to drill a hole in the ice in order to get deep down below the surface. Think about this as, some ice fishing. They decided to carve out a cone from a block of ice to see if they can get to some of the fish inside. Well, that means you're going to be taking out space this time. You're not adding space together. You're taking out part of the object inside that cube. This is a subtraction problem. You got a big giant cube that has a certain amount of volume. And a cube, remember, is just like a square prism. But I'm not going to add the volume of the cone. I'm trying to take out that shape. So this time I've got to subtract volume instead of adding it. So I'm just going to start with the cube. The cube is 6 by 6 by 6. So this one's pretty easy. Here's my cube. Length 6, width 6, height 6. The volume of that is just going to be the base area times the height. The base is a square, so 6 times 6. And then the height also happens to be 6 in this case, so times another 6. 6 cubed is 216. And this time we're doing centimeters. So there's my 216. Now I have to deal with the cone. So if I look at the cone, what they're telling me is that that distance across the top, the diameter of that circular base is 4. And the height of that cone from bottom to top, it's the same distance as this, 6. So I know the height of the cone and I know the diameter of the cone, so I'm going to draw it. Diameter was 4. That means the radius has to be 2. And the height of that cone from bottom to top is 6, because it's the same as the height of the prism. So I'm going to plug in 1/3. Area of the base is a circle, so pi r squared. 1/3 pi times, remember to use 2 and not 4 since it's the radius, so 2 squared times the height of 6 is going to be, extend this a little bit. 2 squared is 4. 4 times 6 is 24. 24 times 1/3 is 8. So that cone has 8 pi cubic centimeters of volume. I got the 2 pieces now, so you got to remember, I'm drilling out this cone from that block of, say, ice. So I need to take out space. So the volume of that leftover solid with that carved out cone is going to be the volume of the entire cube, 216, minus the volume of that cone, which was 8 pi cubic centimeters. Directions asked us to round to the nearest hundredth, so I'm not going to leave it in terms of pi. I'm going to type it into my calculator. 216 minus 8 times, and then the pi button, second exponent button. So about 190.87. And then this would be cubic centimeters. So whenever you do a composite solid, you need to look to see if you're adding volumes together or if you're subtracting volumes. If there's some type of hole cut out of the shape, you're going to be subtracting. If you're stacking the shapes together like Legos, you're going to be adding. That's kind of the big takeaway from that. Okay. All right, the Math Excel will be posted. I will be on from 1 to 2 Thursday and Friday, so log in if you have any questions. Happy voluming.